Today we're going to explore the sequencer model 1601, which is part of Arturia's Arp 2600V3 VST instrument. Arturia's documentation on this sequencer is not particularly good, so let's get in depth. For my initial setup, I have VCO1 controlled by the keyboard. As you can see, the keyboard control voltage input is opened fully, and the sawtooth waveform is routed to the filter. So now when I play my keyboard, let's change this to use the sequencer instead. The sequencer output is down here in the bottom right corner. Our first choice, do we want to use sequencer output or do we want to use quantized out? The quantized output will restrict the pitches, so if we use the quantized out, the pitches will correspond to the black and white keys of the keyboard. So let's start with that, because that output is going to be more traditionally musical. The other output would be more useful for experimental sounds. So I'll run a cable from the quantized out A to this control voltage input of VCO1. Let's try this again. And now we have it. Nothing's happening yet. If I do play a note on my keyboard, no matter which note I hit, I get the same pitch. So the keyboard is triggering sound, but it's not controlling the voltage, and it's not controlling the pitch of the output. We need to actually start the sequencer. Currently the sequencer is set to all the same values, a row of 16 values. You can switch between 16, a single row of 16 in your sequence, or 2 rows of 8 each. We'll leave it at 16, and we'll start changing some values here. We'll adjust the sliders for a rising sequence of pitches, followed by a falling sequence. Now, when I hit a note on my keyboard, it should start on the note that I choose. I'm going to pick a C, and it should follow this sequence. Let's hear if it works. No, nothing. Why is that? That's because the sequencer is not running yet. We can click this push button, and now we see the lights marching along. Now our sequencer is running, so when I hit a key on my keyboard, we should hear the sequence of pitches. And now I've stopped the sequencer. Let's start it again. I'll play a note and play a different note. It should change the starting point of the sequence. Now I don't want to have to push the trigger button to start the sequencer every time, so I'm going to use the keyboard gate to start and stop. So I drag that cable and I make sure that this switch is set to gate. It can be set to trigger or gate. We're going to choose gate for right now, and then we'll explore what happens when we choose trigger instead. And now, as soon as I hit a note on my keyboard, the sequencer should start. An important point to note is that, as I currently have it patched, the sequencer halts When I take my finger off the keyboard, that's because my keyboard gate is patched to the start and stop. So when I push the key down, it starts. When I let the key up, it stops. Just now, it stopped at step 12 of the sequence. If I hit the key again, it should pick up with step 13. If we want the sequence to start at the beginning every time we hit a new note, that's easy enough to accomplish. There's a jack for reset input. We can run another cable from the keyboard gate, to the reset. And now, every time I hit a key on my keyboard, the sequencer should jump back and start from step 1. It's currently at step 4. I'm going to hit a note on my keyboard. As you can see, it started again at step 1. We've now stopped at step 7. I'm going to hit another key. We should jump back to 1. And now, since we're always jumping back to the start of the sequence, it should be a lot more obvious when I start from different notes on the keyboard. As you'll recall, earlier we set this switch to gate. What happens if we switch it to trigger now? I'll hit a note on my keyboard. The sequence begins. And now I'll let go of the key. The sound stopped, but as you can see, the sequencer is continuing to march along. Now I'll hit another note on my keyboard. Actually, I'll hit the same note again. And the sequencer stopped. So what's going on here? A gate is a signal which is initially off, and it comes on as soon as I press a key. And it stays on until I let go of the key, and then it goes off. And so if we switch back to gate, this means that we want the sequencer to respond to a gate signal. We want it to start when we press a key and stop when we let go of a key. Switching back to trigger. A trigger is a short impulse that happens as soon as we hit a key on the keyboard. It comes on and then it goes off. It goes off even if we continue to hold the key down. The trigger is a signal, a very brief instantaneous burst of electricity that happens as soon as we press down a key. And so now we're telling the sequencer, start as soon as you get that trigger signal. But when it's set to trigger, it also stops upon receiving a trigger. And so pressing the key once starts the sequencer, and it continues to run until we press the key a second time, generates another trigger, and stops the sequencer. But as we currently have this sound patched, we only hear sounds as long as we've got the key depressed, irrespective of what the trigger is doing. So as long as I hold down the key, we hear the sequence proceeding, and as soon as I let go of the key, it stops. But the sequencer is still running. So what's going on here? The envelope is still responding only to my keyboard. So the keyboard controls whether the amplitude envelope, actually this is the attack release envelope, controlling the output volume. So even though the sequencer is still running, we only hear sound while the key is depressed. Sequencer stopped because it received another trigger. I hit the keyboard again, sequencer should start, and we hear sound until I let go of the key. The sound drops out because the envelope is being controlled by the keyboard, but the sequencer is still running. If we want the sequencer to continue to play even though we've let go of the key on the keyboard, we need to set it up so that the sequencer clock fires the amplitude envelope. It's easy to overlook, but here in the attack release envelope, there's a switch, keyboard gate or trigger. It's currently set to keyboard gate, so this envelope is only going to fire based on what I'm doing with the keyboard. So I push a key and it triggers the envelope. If we want to trigger the envelope with the clock from the sequencer, first we need to switch this to trigger. Now that wasn't exactly what we wanted, because the default routing, as you can see, is from the sample and hold gate. So if we don't have anything plugged into this input jack and we switch it to the trigger setting, it means it's going to take the trigger from the sample and hold module here. So if let's try this one more time. And now the rate of the sample and hold module will control the frequency at which this amplitude envelope is fired. So I'll raise the rate here. So we want the sequencer to control that instead of the sample and hold module. So we're going to go to the clock out of the sequencer, and we're going to plug that into this input jack. So now we're bypassing the sample and hold module, and we're using the clock of the sequencer to control the firing of this envelope. So now let's switch this back. And now we hear nothing because our sequencer is not running, but as soon as we start the sequencer with a single keyboard note, the trigger will start the sequencer, and it should continue as this envelope is fired again and again by the clock output. Let's see what happens. I'm going to hit one note and then let go. Let's stop it. Okay, what was happening there? The envelope was being fired according to the clock output, but it was very, very short pulses. The pulse width is controlled by this slider. So let's start the sequencer again and see what happens when we increase the pulse width. Okay, do you see what's happening here? The envelope is being fired at every step of the sequence, and each time it's fired, it's being held based on the pulse width. Short pulse width is very quick, brief pulsing sound, and a long pulse width so it's similar to playing without a sequencer if you were just playing notes on the keyboard in either a staccato short strokes of the keys or long strokes. And while we're looking at this, let's start the sequencer again. The clock frequency slider controls the speed of the sequencer. So as we move the slider down, the speed of the sequencer slows down. As we raise the slider up, the speed goes up. And let's decrease the pulse width again. Before we continue, let's switch this back to gate. And as long as we're in this area of the sequencer, what about this FM slider? The FM slider allows you to make changes to the speed of the sequencer clock. So you can speed up the clock and slow it down. With the current settings, though, we'll find that this slider has no effect whatsoever. I'll start the sequencer again. I move the slider up and down, and nothing happens. Why is that? Well, first let's move this slider back down to 0. With no controller signal patched into this input jack, the FM slider is taking its directions from gate bus 1. That's this line right across here, the top line in the gate buses. We'll cover the use of the gate buses in greater detail later, but let's look at how to use gate bus 1 to control the frequency of the clock. At each step of the sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., one of the 3 gate buses can fire. And depending on how these switches are set, you can decide which gate bus will be fired at which step of the sequence. So this means that gate 1 will come on the first step of the sequence, and gate 2 will be on for the rest of the sequence. So let's turn gate 1 on for the first 4 steps of the sequence. As I said before, with nothing patched into this input jack, the value of gate 1 is going to determine how much the frequency modulation of the clock speed will happen. So as it's set up now, when the sequence is running, on the first 4 steps of the sequence, when it's running, the fact that gate 1 is on should speed up the clock. So let's see what happens. Right now, we have this slider set to 0, so it's going to have no effect. Now let's raise this value a little bit. And now as soon as I strike a key, we'll start at the beginning of the sequence. Since gate 1 is on for the first 4 steps of the sequence, the clock should run faster for the first 4 steps, then slow back down to its regular value, and then when the sequence starts over at the beginning, the clock will speed up once more. And now we're slowed back down to the regular pace. Speeds up for the first 4, slows back down. Let's raise this even higher. Now we should have a rapid first 4 pulses of the sequence, and then slow back down to our regular pace. Now let's push it even higher. So the sequence speeds up when gate 1 is high, and it returns to normal when gate 1 is off. The clock frequency still determines the normal pace of the sequencer, so we can raise the clock sequencer slider. Now this will still be very fast, and this will be faster, or not as fast as when gate 1 is high. So clock frequency is determining the nominal pace, and the FM slider is determining how fast it runs when gate 1 is high. One of the ways that we can use this is to add swing to the sequence. So let's set it up so that gate 1 is on for every other note of the sequence. And we'll lower the FM amount to a fairly low level. So what should happen now? Now the clock of the sequencer speeds up every other note of the sequence, and the effect should be that every other note is a little bit shorter than the previous note, and that should give us a little bit of swing. Let's see what happens. Just as we expected. Let's reset our gate buses so that everything is gate 2. And now instead of gate bus 1, let's patch in the square wave from the LFO, the low frequency oscillator. And we'll use that to modulate the speed of the clock instead of gate 1. And we'll slow down this LFO so that we can hear the effect. Since this is a square wave, we should get high speed, followed by a consistent low speed, followed by a consistent high speed, by a consistent low speed. Let's see what happens. We'll reduce the frequency of the low frequency oscillator, and now the effect should be obvious. So this is the low part of the LFO, high LFO, low LFO, goes high again. We could also use one of the envelopes to modulate the speed of the clock, or any other control signal. Let's disconnect that cable, and we'll go back to the gate buses and focus there for a while again. We've seen one special use of gate bus 1 to modulate the speed of the clock. Now let's look at a special use of gate bus 2. If you look at this orange line here, gate bus 2, or gate bus 3, also controls the reset and the skip. What's this useful for? One very useful application is to produce sequences that are less than 8 or 16 notes. Right now this switch is set to off. Let us switch it to the reset. So now gate bus 3 is a reset signal. So when the sequence is marching along and it gets to someplace where gate bus 3 is on, then the sequence will reset. So I've set this at step 5. Now when the sequence runs, it'll play note 1, note 2, note 3, note 4. When it gets to note 5, gate bus 3 is on, so that should reset the sequencer, and it'll move back to step 1. So now we've changed from a 16-note sequence to a 4-note sequence. And let's see how that works. Or we can make it a 5-note sequence. Or a 14-note sequence. And let's see. We'll just turn gate 3 on for every step of the sequence. This essentially turns the sequencer off, because as soon as the sequence starts, it's reset. Now, let's reset this to gate bus 2, and now the sequence should restart at the second note of every sequence, so we're just going to get a repeat of the first note of the sequence. And now I'm just going to step through and increase the length of the sequence by turning off gate bus 3. Now let's change this so that gate bus 3 is controlling whether any step of the sequence will be skipped. So we set it to skip. Right now, gate bus 3 is off for the entire sequence, so no notes should be skipped. And let's turn bus 3 on for these 4 steps of the sequence. So we should get the first 4 steps of the sequence, and then it should skip to steps 9 through 16. Now we'll turn this off so that gate bus 3 no longer has any effect on the skipping or resetting of the sequence. Now let's take a look at these switches down here. We've set this to 16/1, and so our sequence has been 16 notes long. If we switch it instead to 8/2, now we've split the sequencer into 2 pieces, each of them 8 notes. And now we should only be playing these 8 notes. You'll notice that each of these 2 sets of 8 notes is playing in parallel. So this note is fired and this note is fired at the same time, and then the second of each of the 2 sets. When we've split the sequencer into 2 parts, this is part A and this is part B. So when we initially set this up with the output A, that means that when we split this into 2 separate parallel sequencers, that we would be using the first 8 steps of the sequencer to control the frequency of our oscillator. Now let's try patching in the quantized output B to this control. Now using these sliders, we can turn down A and turn up B. So now this section of the sequencer should be controlling the frequency of our oscillator. Let's hear that. So we've got the descending part of the sequencer controlling the frequency. Now part A and part B. We'll disconnect B. And we'll turn A back on. At the start, we chose to use the quantized output of A. What happens if instead we use the unquantized output? Now, instead of well-defined pitches on the keyboard, we'll hear a different range of frequencies that are not tied to the black and white notes of the keyboard. And now we can, of course, control the range of that change in pitch with this slider. Let's increase the clock frequency so the sequencer is playing back really fast. Let's change back to a quantized output. So now we're back to notes on the keyboard. And this is probably obvious, but the sequential and random switch, if we switch it to random, instead of playing the notes of the sequencer in order, it will randomly pick a value. sequencer can be used to control something besides the pitch. Let's disconnect this. Now we're back to keyboard control. Although the clock is still controlling the firing of the envelope. Now let's use the sequencer to control the frequency of the filter. We'll put it into this control of the filter, which was previously the ADSR envelope. Now the pitch won't change, but the sequencer will be controlling the cutoff frequency of the filter. I'll adjust the frequency. Let's disconnect that. We could use it to control the amplitude of the output by connecting it to the envelope generator of the filter. Actually, that was still control of the filter, but it was just control of the amplitude of the envelope being applied to the filter. Now let's turn our attention back to the gate buses. I'm going to switch over to a couple of different patches. Let's examine this patch before we get started. Again, I've set this to gate, and I'm using the keyboard gate to reset the sequencer and to start and stop. But I don't have any different values set on the sequencer because I'm really just using the gate buses this time. So I'm using the keyboard gate to start the sequencer and using the gate buses. I've got the gate buses, gate bus 1, gate bus 2, and gate bus 3 patched into the filter. And right now I have the effect of all three turned all the way down, so none of the gate buses are going to affect the filter. But I do have some output. Now let's look closely at how I've got the gate buses set up. I've got gate bus 1 high on the first 4 steps of the sequence. I'm using a 16-step sequence. And then gate bus 1 is off for the remaining 12 steps of the sequence. So if I turn the effect of gate bus 1 up on the filter, we should hear the filter open up at the start of the sequence and then close up for the rest of it, and then open up again on the first 4 steps. So let's hear how that sounds. And now let's turn up the effect of gate bus 2 on the filter. Gate bus 2 should turn on the filter steps 5, 7, 10, 12, 14, and 16. Let's hear how that sounds. And we'll turn up the effect of gate bus 3. That should come on steps 6, 8, 9, 11, 13, and 15. Now we'll move to a different but similar patch. Now, instead of gate bus 1, gate bus 2, and gate bus 3 being patched into the filter, I've got this output, position 1 out, and clocked gate 1 out. Position 1 out fires only on the first step of the sequence. So let's hear what that sounds like. And clock gate 1 combines, see this and? So it combines gate bus 1 with the clock output. So it multiplies these two. That means that when gate 1 is on, it will play, or it will fire according to what the clock output is doing. When gate 1 is off, there will be no sound at all. So the difference between gate bus 1 and the clocked gate 1 out is most easily understood by comparison. So I'm going to bring gate bus 1 back in, and we'll listen to that. We'll turn the effect back up. Notice that for the first 4 steps of the sequence, gate 1 was on. And so the filter stayed open for that entire period. If we turn up the clocked gate 1 out, that clocked control signal will only be allowed to work when gate 1 is high. But we'll hear it fire 4 times instead of a single on-off. Let's increase the pulse width. And it appears there's one more switch web that I haven't talked about yet. This switch here, what does it do? Well, let's try it and see. We'll start out the way we've had it. And then we'll switch it down. It cuts the clock frequency in half. And while we're here, let's look at pulse width modulation of the clock output signal. Let's control this with the LFO again. We'll use the square wave, so it should be slow, then fast, then slow, then fast. We'll slow the frequency of the LFO down. We'll adjust the amplitude. Let's hear how that sounds. Let's turn this back to the higher speed. Well, that didn't seem to do anything. And that's because I had the mod wheel connected or controlling the LFO depth. So I've disconnected the mod wheel, and now we should hear some effect. It's not really obvious what's happening, but the LFO is changing the pulse width from short bursts to long pulses. There's another tool here that shouldn't be overlooked, which is the use of the quantizer. We used that earlier to quantize the sequencer output so that it was playing only the notes from the keyboard instead of intermediate pitch values. Let's try using the input value, or the input jack here, and we'll put the ADSR as the input to the quantizer and use that to modify the pitch. We'll turn up the effect. Let's see what's happening. Let's slow down the clock frequency so we can hear the quantized decay. So now the frequency of the sequencer has no effect. It's just the timing of the envelope itself. So let's raise the attack time, make it really slow. And now we can hear the quantization very clearly. We heard a fast decay. So now let's decrease the attack time, but we'll increase the decay time. So I think that almost covers everything in the sequencer, excluding the LFO and these global parameter changes, which are not subject of much interest right now. We do have a few other jacks that we can use to control the sequencer. For instance, there's a stop. We've already used the start and stop, but let's try plugging gate 1 bus into the stop, and we'll turn gate 1 on at step 5, and now our sequence should stop when it gets to step 5. As you can see, the sequencer did stop at that point. So we'll call it a day, and I hope this has been helpful in showing you how to use the sequencer model 1601 in Arturia's Arp 2600V3 VST.